Okay, here we go. Are we live? I think we're live. Yeah, nice. Gonna get this going. I think it's working. Okay, nice. It is working. All right. Open chat. Boom. Okay. All right. So, hello, hello, hello. Play some music. Fix that light too. All right. I think we got the context command should be working. So the plan is just kind of rip through some CAD today. Hit the context command for some context, but essentially I found a server rack on the street that doesn't have air intake. So we got had this model which came from the manufacturer of the server rack, but there's no, I found it on the ground outside, so there's no air intake modules. So essentially we gotta do it ourselves. We gotta design something, which is, you know, doable, but I figured since I'm going to be doing it anyways, and since it's kind of a standalone thing, might as well do it on stream. It's been a while. It's been a while.
Reality, transform energy, distance, power, unconscious, infinite, dream, earth, heaven, stars.
internet is being really slow now. That's fine. That's weird. All right.
Music.
All right, so this is other computer is not connected to the internet, which is very weird. But that worked. All right, now we're working. Okay, how does this sound? Sounds good. All right, let's get into it, bros. So, essentially, the idea here is like use slim stuff. So these are the fans. Let me open this. The idea is use pretty small printed parts. Like this is not that thick. 5.4 mils. And it's actually a little too thick. I know because I tried this already. Like I printed a little slice of this little segment. And it was still a little bit too thick. So I think what I'm going to try to do is either put the fasteners on the outside, so like print something like thread. See how like this could actually, I have a better model for this, don't I? Let me try to find that. Either like put the retaining bracket on the outside of the outer wall, or just to make it like so the inside printed piece is as thin as possible. We got, yeah, this model. Yeah, so this is like a fake with the outer wall. So either put like another Yeah, so the idea is like, these are the fans, these three pieces, bang, bang, bang. So have those like retained to the outer piece. Like initially it was like use these captive nuts, but then it's like, okay, maybe that's not what we want to do because it's too thick. Because the problem is there's like a conflict. There's like a space conflict with this bar here, so it's got to clear that. And it has to clear that like with these little dimple deals as well. So I think I'm just gonna get into it. So these fans are based off of a DigiKey part, which I did a bunch of looking at, and like I think like I did a bunch of research trying to pick out what we want to, what the best one would be. And it's like a good balance between airflow, noise, and cost. So you want to try to not have something that's too loud, not have something that's too expensive, but still like be able to fit in place. And there's really not that much going on there. I would love to have them be bigger, have the fans be bigger, to maybe have to use fewer of them. But I think I'm gonna start with this size, and then like just build it, because there's gonna be 3, 6, 9, 12 of them total. So it's a lot of individual fans. So also for one of these pieces, I'm also gonna have to have mounting areas for like a the controller or whatever, because it's not just gonna be like plugged in. Like the idea is I'm gonna have like a separate controller circuit that's gonna drive everything. So we got one of these little like 4 air intake modules is gonna have space for a controller. So I think the first thing I'm gonna try to do, so I did this a while ago. I think the first thing I'm gonna try to do is see what how thin I can get this, right? Because it's got to clear that inner piece, that inner pole thing. So I think that's where I'm gonna start today. Yeah, so we've got to like clear, see how this is like interacting right here? So this is like the door. There's like a rod, like this rod. This is the front, and there's like a handle up here that you twist to like unlock a thing on the back. So it's can't get removed. So I've got to like work around that. Yeah, okay. That makes sense. That all making sense, everybody? Bunch of different considerations to do here. Okay. Yeah, so this is the first sketch. So this is brought in from that outer model. Okay, so I think first what I'm gonna do, is try to make this a lot thinner. Like if I do... We got the nut pockets right here. Like there's a lot of... If you look at it this way. These, I think, are these the half thinness ones? I have those. Switch over here. Ooh, my light is all crazy. Oh, that cute guy. Man. Well, never mind. I think these are the thick nuts. I think these are Dr. Doll. Hey man, what's up? Dr. Doll. What's goody, what's goody, what's goody, brother? Or sister. Yeah, so better than fine. Yeah, I mean, swagging, doing some CAD. So this part right here, this nut doesn't have to be, it can go a lot thinner just because we have, this is like this piece against, like that's where a lot of the thickness here is coming from this nut. So I think I'm gonna draw in this half thickness nut. So let's do that because I don't know if I have, actually maybe I have the McMaster part for it. So let me punch over to that. Blinking, I just did blinking LED with Arduino last week. I know it's hella. Dude, that's literally everyone, 100% of people start right there, man. That is a beautiful place to be. You got a lot in front of you. A lot of good stuff in front of you. Yeah, that's a really good place to be. Where are you, do you have a project in mind that you're trying to work on? McMaster. We got M3 X nuts. Yeah, so these are the thin ones. Is this the part I have though? 1.8. Let me calipers. Yeah, 1.8. So that's it right there. Bang. So that is much easier than having to draw it. So we can go product detail, download, cut this, external, boom. Open this. I want to make a small 3D printed drone. Yeah, bro. That's a good project. It's a good project in general. I don't even know if I could do that. French fries vending machine. Dude. Not bad. French fries vending machine is sweet. Would it like do all of it right there? Like it would, how would the vending machine work? So it would be like, there's pre-made fries inside, or is it like some kind of like crazy robot that like does it for you? All right, so let me open that nut file. Okay, there it is, boom. So see if I just drop this in here like this. Nice, yeah. So if we look at this, whoops. It's already, we save a lot of space there. So we're going to start with that change. So this offset is what? 0.6 millimeters. All right, so not too much. Frozen fries in a fridge with an air fryer, so just control motors in adventure. Ooh, okay. In the fridge with air fryer, so just control motors and temperature. Huh. I think that's definitely doable. In some ways, that might be easier than the drone. If you can figure out how to do, right? If you have the money, that's probably a little more expensive than doing a little tiny DIY drone. But I would actually say those two projects are pretty similar in complexity. Like a scratch, drone from scratch. I guess you can get drone kits and stuff now, so maybe that's not that hard. Or at least not as hard as it could be. But what am I talking about? Those would both be pretty challenging projects. Nice. Community center, that's awesome. Probably have a lot of good stuff there. Alright, so I believe, alright, so this is what we're gonna do. First we're gonna swap that. Then I don't think I need as much depth there, but let me just open this one. So this, what is this depth? 2.8 millimeters. So let's do that. Up to face one. Oh. Is face one not? Let me do this. Edit in context. Okay. So it's going up. So how am I positioning that? Ooh, I did this really quick. This is not super well laid out. What is this? Edit feature. So we got this. And then we got this. It's the fan. Alright, so let's change that. So I think I'm just gonna go like do this. Instead of make this up the surface, I'm just gonna do the width of the nut. Is that gonna break everything? No. Okay, I maybe see why I did it the first time. All right, so let's unabsorb this. This is the sketch. Is it for scene sheet? No, I'm 3D printing this on that printer. I'm gonna 3D print it. It's for a hit the exclamation point context. So I have this server rack, and there's like servers and stuff in here. I don't have intake fans, air intake fans. So I'm doing something, hopefully a relatively quick project to do air intake. Yeah, that's the goal. But you never know. We'll see where it goes. That'd be cool to get it CNC'd. I actually have only had stuff CNC'd like a handful of times, not that many times. Like, yeah, only a few parts, only a few small parts over the years. But I do a lot of stuff with 3D printing, especially just like around here. Okay, so let's do it this way. We'll have the sketch here, and then we'll go, we'll do the first, yeah, so we're gonna go like this. This is gonna be the thickness of the nut, so 1.8 millimeters. And we'll do like the thickness of the retaining piece. Yeah, thank you. So like 0.5 millimeter. So, oh my God, what? This is the wrong way. How did that even happen? Okay. 1.8, and then this would be the thickness of the so we're gonna do this extruded up to surface. Okay, yep, so there's that. So, what are you not happy about? What even is that? Yeah, so we gotta replace that. Yeah, is it one of the full color 3D printers are very, very, very cool. I think like HP makes one. I forget who makes it. Mimaki. Look at that up. Let's pull that up. Oh, yeah. I've seen these before. Oh my god. This is like a bazillion-dollar thing, though. Ugh. Yeah. Come on now. Let's just order this. Yeah, bro. Come on now. Crazy. That doesn't even look real. Yeah, dude. I don't even know what I would do with this. I would just like... Yeah, super I'm stealing a kidney for it. Yeah. I feel like yeah. I don't even know. I literally don't even know what I would do with this. I'm sure I could find something to do with it. Projects to work on with it. Just like make like just do like this stuff, but like just have like the most insane graphics. What would you do? I bet you could make some like a you would do like you probably do like definitely do the drone. Do you like the 3D printed drone but make it like sky camouflaged or something? Make it like invisible if you fly it in the air or something. All right, so we also want this to be really small. Let's see, 0.25 mils. That's like nothing. Ugh. Kind of not even worth having, to be honest. What is the layer thickness? Can that even be printable? So if I did, let me just export this. See what this looks like on the printer. I'm a reactor designer, so I'll do crazy art, man. Yeah, so you're the guy that needs you're the person that needs the printer. The beautiful multicolor printer. I would just print big gray stuff. I would be more excited about the size of it. Here. Alright. Oh yeah, that's right. I'm gonna have to do this in a couple parts. It is too big for the printer to do it in one piece. But if I did so I can do scale just to see how the little bottom pieces, if they could print. Yeah, I don't know. That would be kind of sketch. I think we're gonna try it though. So 0.2 millimeters. So if I do 0.4 here, it's 2 layers. Which is not that much, but more resolvable to print. Okay, So what do we got next? Okay, those are the holes. All right. So now this is what I wanted to change. So now this. Okay, I kind of did this in the wrong order again. How much time will it take to print? Not very long. This is going to be tiny. So probably the estimate here is 2 hours for this piece. The final one's going to be a bit bigger, but not like functionally 0. Very little time for this kind of thing. Especially because like I normally just mostly print stuff at night, like while I'm sleeping. So like let it run in here. Yeah. So anything less than like 12 hours is like not that much time. Unless of course you're like trying to work on something that you want to like do iteratively. Then it can kind of seem kind of slow, but not really, to be honest. All right, so we wanted to do, this is going to be 0.5. And then the other one is going to be 1.8. So now, that is the wrong way though. No, it's not. Okay. Okay, so wait, I'm confusing myself here. Awesome stream, dude. My break ends back to coding. Yo, Dr. Doll. Nice checking in, bro. Good luck with the Arduino thing, man. Or the French fry robot. The French fry robot actually sounds really fun. And I would definitely, like, use that. Thanks for the nice words, though. For real. Have a good rest of your night. Okay, so I've confused myself pretty significantly here. But I guess not. So I guess if we just do this, reverse this 1.8, and then thank you. 5. Yeah, okay, so that's how I gotta do it. So we're gonna do, so this cut, which is the nut pocket, is going to go up to surface, plane 4. So that should be, whoa, That's the wrong way. Why is it this way? Oh, okay. So yeah. This should be evaluate. This should be 1.8 mils. 1.8 mils. Nice. Okay. So now what do we got? We got this. This is probably going the wrong way. Yes, it is. Reverse. We're gonna do. Let's make this huge. 50 degrees. Let's just make the. Whoa. Yeah. Okay, and that is the wrong plane. Yep, okay, boom. What's this? Okay, so what's wrong with you? Let's put that back here and do, yeah, okay. This little thing here is annoying. I'm gonna do I'm gonna do another 50-degree cut here. So this is gonna go 50 degrees, draft outward. Yeah. Direction 2 through all. Nice. Ugh, almost. I'm gonna give this a little bit more juice. Do 75. Okay. Actually, that's not even gonna be printable, so the max we can do there is like 45. So it just makes more sense to maybe delete those. So probably this one, that one, and that one. Actually, probably just that one and that one. So let's delete. This is very dumb. Let's do it like this. This is like the grid pattern of the air grate. We're gonna go like this. We're gonna do another one. This little bean. Go like this. No. Let's go. Three. Let's go. Two. Let's go. Okay. Now we're gonna extrude cut that. Flip through all. Bang. And now those two little deals are gone. Oh, I should get rid of those two as well. This one, this one. Okay. So now we gotta repattern these pieces. So I'm gonna do that. So we want to do sketch pattern, sketch driven pattern. Want to do these features. Nice. So now I have all of the nut pockets. Okay, so now let's go back to this. Yeah, it's gonna freak the fuck out. Okay. So we're actually just gonna get rid of all of this nut. Yes to all. Whoa, fuck. Mates. So who does it? Yeah, it's gonna be this face. Yes. Supposed to be this? Maybe. Okay, so let's repopulate those thinner nuts. Actually, before we even do that, how does this look over here? Yeah, it's gonna be like, oh my god. So you want to hit this, and this, mate, boom. Oh yeah, that totally clears. Maybe it doesn't. Okay, I actually think we should maybe print that test piece and see how that looks. Maybe I wrote this. My notes. Oh, nice. Okay, so you got 19.515 is how thick it can be. So if we do 17, so we got 2 millimeters of clearance, which is workable. That means the screw heads over here are gonna have to also be pretty thin as well. Okay, so this will work. Let's keep fleshing this model out. Hide the fans so I don't accidentally use them to mate. So it is annoying, and if people know a faster way to do this kind of work, that size, yeah, parallel. That is a close fit, but we should be okay. But I always like, basically, I always try to make my CAD models, like if I'm using the fasteners and I can find the fastener model or whatever, or anything where I have the opportunity to like make the CAD drawing more accurate, I feel like it always results in cleaner projects, just because like it's just so much easier to like catch the other way to find out about like if something's undersized or something's gonna collide or whatever is by like building it and then finding that out, which just adds so much time. So even though it's like wait, I want that to be parallel. Even though it's annoying to go through and make the CAD model really detailed, at this point I would rather spend the time and have the build be cleaner. I don't really get a ton of time, or like, you know, when you invest the time in deciding to work on a project, it's easier to do like bits and pieces of the CAD like when you have free time, but the builds always take like, you have to do like uninterrupted basically, in my experience. Like it's hard to stand up halfway through like a soldering job or halfway through a like, if in this case, like I would find this out if there's problems. I'd find it out like my whole server and everything's down, and like, okay, then I gotta go back through and fix this. So it's, I don't know. I'm rambling.
The people come together. Makes it feel good.
Yeah. So just going through here and installing these nuts in the CAD model virtually. And you get the benefit of like SolidWorks lets you do things like bomb creation. So when you get to the point, like if you actually do have a true to life CAD model, you can export a parts list, you can get like the counts of whatever components you need. Makes that process a lot easier rather than having to like, okay, how many did it actually use? You just get the software to tell you.
Drifting off to search for something new. I don't know if I'll be coming soon.
Easy, easy.
I'll be sailing. You've been waiting. Feeling lonely. Don't erase me. Please don't always focus on my flaws. Or always say what I've been doing wrong. The sea's changing. I've been tired of waving. You keep drifting when no one's listening. Mathematic waiting. Elevation lonely. Cinematic race.
Okay. Did I lose one? No. It's right here.
Used to walk around so terrified. Now I feel like I am more alive. Deep beside me, don't deny me. Keep it clear, babe. Call me highly. I can feel these reasons.
Two more.
What's the point of always giving up? Keep 'em looping.
Okay.
Like the echoes, I'm trying to hold you. You wanna let go.
All right. So now we got the nuts installed.
Now it's time to take this final ride. Trying to free you from this state of mind. Need some freedom.
Okay.
Screaming.
So we have two-ish. Let's fix this first. Actually, no. We're gonna go here. This is what I care about. Yeah, this is gonna be like.
They're just different. Need connection. Too much static. So electric. Keep it clear.
Why is that the plane? Who cares about that? Maybe like this. This. Yeah, okay. So, alright. So this is it installed. I'm actually going to change this piece's color. Air intake grill. So this is like the fake. This is just a cutout of that bigger one. Appearances, metal. Let's do metal, steel. Let's do sandblasted steel. That is a very similar color. I was looking for black. That's funny. Alright, if I do magnesium's dark, it doesn't really matter because I'm not going to be using the cast lead. That looks cool. So this is like the outside of the rack. So that's this for people watching. That little grid is just like a cutout of like one of these intake grills. Does that make sense? Just to like, so I don't have to work with that big ass model. I can just use the little grill there. All right, so let me look at what we got here. Okay, so oh yeah, so I want to add a plane off of this. I think I'm going to add it to the part. But I think I'm going to do it from within the model. So we're going to go to this thing. Going to edit this. So this is 19.515. So this is where the bar is. 515. So this is like the bounding box. So I'm going to call this the bar edge plane. So nothing can come off of here. View, hide, show, planes. Ooh, gonna hide those. Bang, bang, bang. So, do have like 2 millimeters. Oh, you cut out. I'm back. Oh man. Just the video or the audio too? Damn. Yo, small, beautiful Asian. Excellent name. Very good name. Just video cut out. Weird. Alright, well, yell at me again if it freaks out. That's annoying. Okay. So we have 2 millimeters here. Basically, actually, what is this number? So we'll do evaluate, measure. This to here. 2.215 millimeters is what we have for the screw heads. And I don't think that that's that much. For the screw heads. In fact, so if I were to do Maybe McMaster sells something that's that small. Let's take a look. How much room do we actually have here? So if I go hide this, so measure from here to here, it is 17.3 millimeters. Nope. So if I go bolts and screws, oops, metric, M3, ultra low, bro. 1 millimeter head height. Length is 1 millimeter. Am I selecting for that? No, length. 14, 16, so... Ooh. $5 each? Nah. Let's do just regular low. Okay. 25 for $3. So 4 times 3 times 4. 36. So I'd need 2 packets. If I do the 50 pack, this is still cheap as shit. 100 pack for $12. Super corrosion. Yeah, so I do 2 of these. All right, so let's say fuck it and let's add this to the model. Okay. Boom. Okay, so if I mate this in, oof. That's pretty beast, bros. So that fits in. Ooh, it's actually very close. I think that'll fit. Is there any other option? Back to McMaster. $16 and then $20. $20 would be way too much. So let me see where that would end up. So if I do this, reference geometry, 20, flip offset. Yeah, that's not gonna work. So it's 16 or bust. We don't have a ton of room. I actually think it's fine because I can bring that first dimension in a little bit. Right now it's half a millimeter, which is honestly already like nothing. It is this much. So I think we're gonna just be happy with 16. Yeah. All right, we're just gonna do that. So we're just gonna spend our way out of this instead of having to be clever. I think I probably have 16 mil regular size ones, like not low profile bolts, so it can try those first. Let me actually go check it. BRB. Yeah, I have them. So I have, this is what like the regular one would be like. So I'm gonna I can try those, and if they don't work, I can do a McMaster order to get the low profile one. So we're gonna do that. So I'm gonna draw or add the rest of those to the model. Yeah, that's what we're gonna do. So let's add the rest of those. To the model. Yeah, so we still have, oh, it's very close. That's the clearance now. So we don't have a ton of room, but I'm pretty sure that this number is not totally precise. Like the outer plane thing isn't 100% right. And I probably have a little bit of wiggle room for like installation. Remember the pole is going to be like midway down the fan. Where did that thing go? It's right over here. So it's not going to be like interacting with the bolts, but still. Oh, I'm doing this wrong. So this is... We don't want to do that here. We want to do that here. Okay. All right, so let's add those Low profile nuts. There are no low profile bolts. Excuse me, Jesus. Boom. Look at this. Man, there's like one thread of engagement there, which is not a lot. Not a lot. So let's bring that in a little bit. So we know it's going to resolve to 0.4 millimeters anyways. So if we just do that, 0.4, give ourselves 100 micron. A little bit better. I also want to do like dust filters on these. Yeah, I actually have them modeled already. Unsuppress. Yeah. So these are actually going to mate to the dust cover. Why is this not? Aren't you in context? Edit in context. Ah, there it is. Nice. Yeah, so we want this to be mated to the dust cover, not to the fan, because it's going to be sitting on the dust cover. But these things are like mad thin. Let me see if I can get a picture of one. That was another reason for these fans, is because they have insanely cheap dust covers, because they're for like desktop computers. Yeah. Amazon hit me with the incognito. Yeah, so these dust covers. So these are like tiny, 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 tiny. So they're gonna add no thickness, but should hopefully keep bigger stuff out of the thing. Don't really know how I'm gonna clean them. But that's so funny. Dude, what is this product page? Yeah. So my attempt at drawing those is this thing. So let's add the rest of the screws. So I'm gonna make a new component folder here. It's just called hardware. We're gonna change this meat to be this. I wonder also how accurate that drawing is of the fan. Why is my thing not working here? Alright, so we're gonna do this thing is just gonna double check this drawing really quick. Depth 15 millimeters. Measure. Yeah, 15. That's accurate. Okay. Paranoia is good. Very easy to make mistakes. Okay, so let's add these bolts. Yeah. Okay. So now I have all of those here. This will be faster. My GPU is like, bro. Oh, wait, I'm in the wrong thing. I'm in the wrong model. Shit. Delete all those. We want to go to this one. This song is crazy. A little better. A little better. Yeah, okay. So we're gonna do that in this model. I was being very foolish. Saving my work. It didn't crash. It's happy. Everything's fine. Okay. Yeah, these fan covers are slowing everything down. But it is okay, because I will suppress them after I'm done with these mates. Okay. Did I lose one? Who are you? Yeah, I lost one. Alright. So now we got all the bolts in place. And I think that is pretty much it for, like, this is manufacturable at this point. So now we got to start thinking about we got to think about what's up electrically. And the fan, the filters I might do like not on the back of the thing like this. I might do them like in between the fan or the printed piece and the fan, just because then I can get at it easier with a vacuum, like through the outer piece. But I think for now, this is good enough. Not good enough. This is great. All right. So other thing, these are going to be red. So let's change that color to red. It's going to be red plastic. Red. High gloss red plastic. Bang. Okay, so the next thing that we're gonna have to do for these is think about how to power them and how to control them. So essentially, I go into this a little bit in the overview video. Yeah, this is looking good now. But we want to have, I'm imagining the way the system diagram is going to look is like you have one of these has all of the smarts on it. So there's going to be 4 of them installed in the rack. There's going to be 4 of these installed in the rack. And one of them, probably the one up here, this one, is going to have all of the smarts in it. Because that'll just be yeah. So, one of these will have the smarts in it. And the rest of them are just going to have electrical inputs. So honestly, I've been thinking about this a little bit. I don't really think it's necessary, because if I do just one of them is like the controller, and then the rest of them are just driven by the controller, I don't have to think about I don't have to think that much about the software and electrical design, because each of them doesn't draw a ton of power. Each of them only draws 2.5 watts. So it's 12 volts. Yeah, so it's like each of them is drawing very little power. So each module is going to be drawing, like each trio of 3 is going to be drawing some fraction of 8 watts, which is not that much. Because I was like, okay, what if each of them gets a temperature sensor? That means each of them would need a microcontroller pretty much. Or I just have the smart one Whoa, there's me, dude. I just have the smart one. Have two. Oh, it's cutting in and out. I think my bitrate is too high or something. It's cutting in and out here. Live unstable. Dang, dude. Maybe it's not. Maybe that's just me. Okay, so I think that's what I'm gonna do. So I think what I'm gonna have, like, one of these is gonna be the smart one. It's gonna have the BeagleBone in it. That's gonna have the inputs for temperature. Because I think if it's like, I can get the intake temperature from one module, the intake temperature is not gonna be different for the other 4 inputs. It's all like the same room. So if I can get it from one, I can get it from basically all of them. And then I think eventually I'm going to have an exhaust situation as well. And I don't know if that is worth talking, but so it'd be great. Like this thing has a huge back. That's the front. Let's get it more into this model. So this is like a glass pane on the front. And then there's, if I can find it, the model from the manufacturer is very crazy. I'm getting closer here. It's just like, it's like an imported step file. So it's very, like, nothing's like named and there's no hierarchy and blah, 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 blah. Complaining. Where is bro? Okay, yeah. Okay, here's the model. It's got this big ass rear piece. It's like a door that like closes, opens and closes. So, it'd be awesome to have, like, knock out one of these and have this be an exhaust fan, because I have an air conditioner that I can plumb the air conditioner's exhaust out with this, but like in addition to this. And so I'm thinking about maybe getting the exhaust air temp as well, because then you could do some cool, at least monitoring, but then you could eventually try to like scale the speed of the intake, or like the amount of the intake, and do some kind of feedback. And I think I don't really care about the RPM of each of the individual fans. I think open loop feedback for just basically just setting the voltage to the individual output modules. I think that's good enough for this. So I think that's the plan. I think that's what we'll do. So so we're going to have 2 configurations for the printed piece. One of them to have the BeagleBone, and one of them to have, so there'll be one of those, and then there'll be 3 that are just a DC barrel jack. So I think we can start working on that. First though, let me go check how many DC barrel jacks I have. Okay, I have a lot. We got quite a number of them. Let me actually cut over to that. We're gonna try the bench. Bang. Ah. Okay. So, let me just get this in focus here. I'm looking at OBS. Key focus. All right. So, I have a bunch of DC barrel jacks. All this stuff. What did I think I likely have enough to be able to do this without having to buy any more. But what I don't have are the other ones. Yeah. Let me get the rest of my stuff. I'll be right back. So it's not like it's a ton of money to buy more stuff, but then it's just like you can't, like, I had to buy these and now I have them just everywhere. So I got three of these and three of these, which is coincidentally the exact number that I need. And I could use, whoops, just combine those. And I could use, could use these for the wires. But that isn't great. And I could probably, I think what I'll probably do is use these three for the just like the simple drivers, and then use probably use these for the PCB, because I like these in their surface mount. So we're probably going to do that, and I'll probably end up buying... I'm going to go look at that right now. So the output will have, the PCB will have 3 of these. And the inputs to the dummy ones, we'll use these 2. Yeah, but I've already kind of used these. Oh, there's another one right here. Yeah, I'm gonna just harvest. So I got 2 here. We're gonna harvest one of these. I'm gonna put everything back. But I just got to be careful with the installation of these, because you can't really take these apart once you wire them in. Whoa, that looks nuts. That one looks really bad in there. I guess that's fine. Jesus. Yeah, bro. Okay. So we're gonna use, and I think I'm gonna use, okay, this is the plan. I'm doing thinking and talking. So that is gonna be for the dummy modules. These are gonna be on the brain one. And then I'm gonna just buy more of the, like, these male ends for that. Is like for this? I think so. That's kind of dumb. I don't know if I need that. Yeah, whatever. All right, so that's what we're gonna do. So we're gonna harvest the third. We're gonna use what we got here for that input, and oh, do I have fucking CAD models for these? That'd be annoying if I did not. But I should. I don't remember what I used these for, though. Nice, we got little dust covers. Just kind of useless. That's okay. Man, that light is bright.
Time it goes
Okay, I'm throwing these away actually. I'm gonna keep 2. This is all getting kept. Not using that, not using that. Not using that. Where's the other bin? That's right here. You're coming with me. You're staying here. Let it. Okay. That's the plan. So we're gonna go with kind of hacking this together. But I have these, might as well use them. Alright, back over here now. I'm gonna re-aim the light at myself. Might look nuts. Alright, that's a little better. Probably need a dedicated face light. Okay, so let's start thinking about the 2 configurations we're gonna have here. You see? I'm just trying to like look here through whoa, man. Handle out DC. I got it. I found the model I made of that barrel jack. Oh, we're fucking chilling. We're chilling. Projects. There, intake. Intake module. External. Boom. Boom. Alright, so I already got this model. Fuck yeah. Did I ever get better than this though? Pardon me while I search. Got that nice one. These are just pictures. Okay. So that's gonna be kind of the first configuration. It's gonna have just a barrel jack. I'm just gonna do the wiring point to point. And then the second configuration is gonna have the BeagleBone. Alright, so let's start working on that. So if we think about this, let's think about this guy. I do want a little bit of room there. So this is pretty easy. So I'm thinking now of like, okay, how am I going to manufacture this thing, right? Because if or how am I going to print this thing? Manufacture. So if I look at this, yeah. So if I export this, right? This is too big, basically, is what I'm thinking. This is too big to be printed like this. Even if I rotate it, or like, there's no... I want to cover And how much am I leaving? Okay, this is not the model I should keep opening. Oh, I have to do these little input piece, like retaining it to the thing. I should probably do it before I do the other pieces. But so if I look at this, yeah, I'm leaving like no room. And I do want to try to cover the inlets as much as I can, just to like force all that air through the, like, force all that air through the fans so I can hopefully catch the dust. I gotta retain these too. I keep forgetting to do that. So it would be nice to be able to, let's think about like how, so if the controller is up in this corner, this back left corner, because my networking switch is up at the top here. So it would be nice. Let's put it this way. It would be great if I'm like trying to reach back in here. Like if I'm putting my hand, like if I need to get to this stuff, like get to the cooler, at least get to the BeagleBone and get to the wiring. If I didn't have to like reach back through that little gap, if it was all like here in this area, that would make my life pretty easy. And because I'm probably gonna, the way I'm probably gonna manufacture this thing is in 2 pieces. So I'm gonna probably do something like this. So let's do, can I split this? Why can I not split this? Split. Bruh. Split. I'm probably gonna, probably gonna split it in half this way and print it vertically is probably what I'm gonna do here. So like this. So like this is gonna be the piece that's gonna be sitting on the printer like this. So like the printed piece is going to be vertical like that. And if I'm doing that, I can add more onto the height. Because like the print bed, and that means I can do them all in one job. Which is very cool. Then you gotta do supports. So if we, let's mock that up. So let's go here. Let's take this. Let's go like this. Let's do let's extrude cut this whole thing. Through all. Boom. So now let's save as. STL. And module body split. So this is probably how I'm thinking about printing them. Because I can't do it the other way. So if I'm doing that, if I'm doing it this way, I have a ton of room in Z to be able to work, to be able to add more details. So I think that might be the plan. And a lot of the strength is going to be added. Like this cross sectionally is pretty thin in some places. Very thin in most places. But a lot of the strength is getting added. One, this doesn't really need to have any strength at all. And two, the fan is going to be like bracing it. Yeah, what does this look like? Ugh, that is like nothing. It is a single layer. So I guess my 2-layer thickness thing is wrong. So we should probably bump that back up. It's very thin. Kind of thing you should probably not be doing stuff that's 1 layer thick. Let me... If we double it, yeah, it's gonna freak the fuck out. What happened to the other half, bro? So does this engage? It does not. Okay. And now we're hitting over there. Yeah. We can kind of take it off of this feature though. It's already. We make this is now very small. How thick did I say these are? Okay, so pretty tight tolerances, but if I'm being honest, why is that not letting me change this? Actually, I think that's literally from the data sheet for those. Evaluate, measure. Measure. So they're 80 millimeter fans, so we go 80 millimeter dust. Relative. Ooh, no, we can't do that because we don't have any room. Yeah, this is where I was at before.
One more time.
Thickness 0.5 millimeters.
One more time.
What is this? 0.1 inch, that's like 0.2. Yeah, so this
One more time. We're gonna celebrate.
the dust cover
Don't stop the dancing. One more time.
is worth doing.
Oh yeah.
Alright.
Stop the dancing. One more time. We're gonna celebrate. Oh yeah. Alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah. One more time.
So if I switch back to half a millimeter for that back wall, which is very small.
One more time. We're gonna celebrate. Oh yeah. Alright. Don't stop.
I didn't really get me through an engagement.
One more time. We're gonna celebrate. Oh yeah.
What is this?
One more time.
Is it a fucking nut? That's right there.
I'm just feeling celebration.
Or select other.
Celebrate. Don't wait too late. No, we don't stop. You can't stop.
Why is this not showing
We're
on
gonna
here?
celebrate. One more time.
Okay.
One more time,
We get a little bit of thread engagement.
one more time.
Really not that much.
You know we're gonna do it right tonight.
Okay.
Music's got me feeling the need. Yeah. Come on. All right. We're gonna celebrate one more time. Celebrate and dance so free. Music's got me feeling so free. Celebrate and dance so free. One more time. Music's got me
I'm fine with it. We're gonna go for it.
celebrate
We're gonna see how it goes.
free. One more time.
We clear it.
Feeling so free. We're gonna
Not really. We come close to clearing it pretty much everywhere.
one more time. Music's got me feeling so
We come close enough. All right.
celebrate and dance so free.
So let's work on this.
Music's got me feeling so
Let's go back in here.
celebrate and dance.
Let's delete. So that's the plan.
Music's got me feeling so free. We're gonna celebrate
But I can add
so free. One more time. Got me feeling so
some thickness
celebrate and dance so free. One more time. Music's got me feeling so free.
to this now. So if we think we're gonna print it the way that I want to, vertically like that, we can thicken the model. We just have to leave a hole for the fan. So let's do that. So this is 80 millimeters. So we're gonna go like this. We're going to find this sketch. We are going to make a new sketch. These two, this and this. This and this. You guys are equal. This is, whoops, that's 80. 80? Whoa, I'm on the wrong scene. You can go like this. You can go like this. So this is going to be like the bounding box. The bounding box for the fans. So this is just going to be a little bit of wiggle room here. So we're going to make this 2 millimeters. Yeah. It's going to be like, where do I end? Over here. I'll show you where you end. Just in case there's a little bit of extra on the fans. And this is equal to that. Should be good. Nice. Okay. So, and now we're also gonna do offset. No, we're gonna do select invert entities. So this is gonna be Where's the wire on the fan? Wire is here. So this is a picture. So the wire's like here. So we'll add that cutout, but we can add some thickness to the model this way. Okay. So is it black? No. So then if we slice this in half and print it vertically, there's like a lot more. Let me actually show you that. Let's just double check. Yeah, see, now if we print this vertically, there's a lot more part there we can use. So, yeah.
Work it, make it, do it, makes us harder, better, faster.
Mm-hmm.
More than power, never. Ever after work is over. Work it, make it, do it, makes us harder, better,
Mm-hmm.
faster, stronger. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever,
So the other thing I was thinking about doing
harder, make it better, do it faster.
was like air guides.
Hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better.
It kind of complicates things. What would be really cool. Ugh, yeah, over here should just be brutal. To try to bring the air to the front. Like, try to push so the air comes in here and it would end up over here. Is the idea with the air guides. That would be fucking gas. So I'm actually gonna try to, I'm gonna look at that real quick. So if we did new part, so essentially you have like call it this is your rectangle, so it's 220, call it by 150, 100, 120. Then you have go out a little way this way, and then we go this way. All right, this is going to be easier to explain. If I can just draw it. So we're going to attempt to draw it. Plane, boom. So we're gonna do this plane, this line? No. Yeah, okay, so like this. And then you have another deal, another outlet. Oh, I have to do this. It's very cool, and it's not that hard. I think I can do this. Why is the origin there? Okay, yeah. So then you do swept base. No, you would do a loft. From here to here along this curve. So I think I actually have to make that a curve. It's gotta be like this. Coming off. Maybe like this. Alright. So we're gonna do locked from here to here. And this is our guide curve. It doesn't like it. Normal the profile. Normal the profile. Is it too? It is too extreme. Guide curve is invalid. It does not interact with section 1. Oh, does it not like that it is? So if I clear this. Yes! I don't need the guide curve. Okay, so this is my idea for the... Oh, I have to do this. I have to do this. So my idea is like do this, insert component. Oh, I haven't even named it. We're gonna name it. Mock air guide. So that brings the air to the intake of the computers, which is in the front. So if I do insert component, mock air guide, yo, crazy looking. This is the idea with this. This is pretty fucked. You see it though. Does this make sense? Oh yeah, bro. So that would be the plan. Would be to kind of angle the air to be able to blow the air right towards the intake of the computers, or at least try to. At least try to. So I think because of how easy that loft was, I think I'm gonna go for this as well for this project. Yeah, why not? We are 3D printing it. We can 3D print anything. Okay, so that's crazy mode. So the air guide, this will be hollow. This is actually, yeah, so this would be hollow, so let me do that. Shell, where's shell? There we go. So, height, really thin, 1 millimeter thin, fuck it. So, that's the idea there. But we're gonna need, gonna need a few things. We're gonna need a way to work around that pole, and we're gonna need a way to mount it to the rest of the assembly. And that'll be for both configurations of the module. So I think I'm going to do that here. Let's just assume, though, for the air guide that I'll put the fan modules in place and then install the air guide like onto the fan modules, because I don't think otherwise I'm gonna be able to do that. Because there just isn't a ton of room in there. Yeah. All right, so I'm gonna do nut pockets for the air guide shroud thing. Okay, so let's do okay. If we assume the split is going to be the front plane, I think we do like 4 nut pockets for the shroud on either side of the plane. So let's do okay, so we're gonna flip this. 3 millimeters from there. All right. Oh wait, we gotta do these guys first. Okay, let's do that first. So we have to affix this thing to the outside. We have to like affix the fan module to the side of the server rack. Like if you look at this model, there's like nothing holding this thing in place. So the plan was like use these corner pieces for that, like these bits up here, just so they're out of the way. I suppose. Nah, I don't want the holes. I suppose you could just leave them, but I don't want that. I don't want like just holes in my thing. All right, so this is gonna be easy. And it's gonna be for every configuration. So what we're gonna do,
It really didn't make sense just to leave this unresolved. It's not hard to go the
I'm gonna go
distance when you finally get involved.
right plane. Give it 5 millimeters of plastic to mate against. And we're literally just gonna take this exact geometry.
The feeling's getting strong. It's been much too long. I feel it coming on. The feeling's in my bones. It's been much too long. I feel it coming on. The feeling's getting strong. It's been much too long. I feel it coming on. The feeling's in my bones.
Alright, we're gonna get it in the way.
Can you feel it? Too long. Can you feel it? Too long. Can you feel it?
This guy right here, bang.
Mm. Yeah. Mm. Yeah.
Yes, yes, yes. Horizontal, okay. So take this bitch.
Yeah. Mm. Yeah. At last, the long wait is over. The weight is off my shoulders. I'm taking off
Oh no, this.
my mind is set so free. I'm where I want
So we want to do.
to get the best of me.
Ooh. I don't necessarily have to use the thin ones here, but they're not more valuable. I do have a lot of them. So let's just. No, let's not.
I see you feel the way I do. The feeling's so true. The good feelings coming through. My mind is set so free. I'm where I want to be to get the best of me.
2.3. So if I do 2.5, that's plenty. So 2.5. So no draft. And then what we do is we find that cut and then we continue, because this gives. So if you have this be straight, like that first part of the cut is straight, and then we do a new sketch, and then you draft after that. Convert entities, and then we exit. Nope. So boom. So if you look at the cross section of this, which I'll do in a second, through all draft outward 5 degrees. So this has been what I've been doing a lot recently for nut pockets instead of threaded inserts. So if you have this little straight section, so if I find this. Yeah, if we cross section this. So this little straight area, this straight part of it is really good for like holding the nut in place. And then this drafted area is good for like making it easy to install. So having the straight section there makes this a lot easier to do. So now we're gonna copy the other half of this, which is this hole, which is 3.25. So we're gonna take that plane 7 is. I'm gonna take this. Oh, it doesn't have to be, so we shouldn't. So we're gonna have this. Same size. But this is gonna be concentric with the inside of that hex. Yep. So through all both. Boom. Okay, so now we have to pattern it. So we're gonna do front plane sketch, and we're just gonna put 3 points on the other locations, and then we can just pattern those cuts from before, so we don't have to redraw them. Which is way better. Okay. Sketch driven pattern. Sketch. And then we're gonna use this. Boom. So now we got all of those other holes. Hide that. Since we're printing this vertically, I can make this a little bit bigger. Give me some more room over there. Let's just see what that looks like. Yeah. Let's just do 4 millimeters or 3.5. I don't want it to be too crazy in there. All right. What if I... No, I can't fill it because we're gonna use it later. Okay. Get ahead of myself. Let's go back into... Uh-oh. This is initially the time to stop streaming song.
I'm gonna take it step by step. There is some kind of poison in
Fuck it though. Okay. Let's add those additional nuts in. Again, they don't have to be thin, but I've got them. I'm not using them for anything else, so they're gonna be thin. And like, there's no like force here. There's no like there's no real like load capacity. None of this stuff is heavy. Nothing is in extreme amounts of tension. It's basically just like gluing it in place. So the thin nuts are totally fine. Printed threads would probably be totally fine, but printed threads are very easy to ruin in M3. Do I have to be using M3? Probably not, but I have a bunch of M3 stuff, so that's what we're gonna go with. This kind of stuff, man. Stuff like this where it's like, this is a personal project. I'm not worried about the manufacturability because it's just me making it. Okay, so now we gotta do these caps. You're gonna look a little goofy. There's no way to do this without it looking a little goofy. Ooh, we could actually kind of swag it. We have to swag it. Psych. Yeah, we got a swag. So you see what I'm trying to do here? So this is what's gonna hold the fan module up against the side of the rack. So let's do this. So if we do evaluate, man, this song is good. If we do, whoa, man, what the shit? Arc length, nah. What is the center distance? Center distance, 100 mils. Easy to remember. Okay, so I'm looking at, that's so funny. I'm looking at the server rack, which is right here. Yeah, that's gonna look cool if we do it. Okay, we're gonna do it like this. This, boom, 100 mil. And we're gonna do circle like this. Like this. It's actually real. Yeah. You see where I'm going with this? And then this is going to be the same length. This is going to be, these are going to be horizontal. These are going to be equal. What the fuck? Okay. Psych, they're not going to be equal. These two are going to be equal. Psych, they're not going to be equal. Why is that impossible? What? This is relation. Yeah. Okay. Yeah, that's the idea there. Okay. Ha ha ha. Is that who I think it is? In the mother freaking chat. Yeah, let me get the soundboard ripping.
Show me your moves. Show me your moves.
I have extensive gongs. On the Twitch profile. Yep. Can I fix that here? Channel. Oh, weird. I have it updated on mine, but maybe it hasn't like propagated. Alright, enough distractions. No, I want this to be... You're welcome, Fresh Fish Sandwich. Enjoy the rest of your night. So here's the plan for this. Ooh, can I make these... Yeah, so let's do it like this. What the fuck? So let me make, let's try this as 30 first. Oh, it's also 30. Let's see this as 20. Nice. What is undefined here? Oh, nothing is undefined. So then we're going to take this and mirror it. Actually, we're just going to do the part like this. So add fillets in here. Bang. So this is going to be like the retainer. So what should I call it? Fan module retainer. Retainer. Is that how you spell retainer? Yeah. Find fan module. Okay, so fan module retainer. Yeah, that's cool. If I can get it to work. Alright. You. Boom. Alright, let's make that a little steeper. $60. Maybe 50 millimeters. 27. How does this look? Whoa. Alright, we're doing that. That looks bitchin'. Okay, so now we gotta do fasteners for this piece. So this doesn't need to be this thick at all. You can make this. Six millimeters thick? What is... So roughly... This is going to be a lie, but roughly how far away are we talking here? I'll use... Do I have 20s? Let me go look. I'm back. We're going to use 25s. They got a bunch of 25s. Because they got a bunch of 25s. Okay. How big is the stream file right now? It's probably big as shit. Oh, only 8 gigs. That's not too crazy. Okay. So we're going to use M3 25s. So it's like 6. Okay. Add a little hole here. Just make sure the top of the screw head is flush. Bolt head. That doesn't seem right. 5.45. 5.45. It is a 3.5. 3 point. Depth of cut. Extrude cut. .5. That's good enough. Okay. Mm-hmm. Is that crazy? What is this? This is 20 millimeters. What if I make it 5? It looks bad. And elephant's foot. That is looking nice. And we can print that in one go. And then let's make sure we get the right color. What color is this again? Copy appearance. Retainer, appearance tab, paste? No. Oh, what the shit? The whole part. How can you? Okay, goddamn. All right. That's the whole retainer there. So that will keep the, we gotta get the 25s. Gong time, gong time. We gotta get M3 by 25. Bam. Socket head screws partially threaded. $8. I already have it. I just need the model. Boom. Now we're gonna go back here. There it is. Why is this no longer valid? I guess we do. Let's use 20s. I guess we do, if we can. Might be good just to have this flush. Yeah, let's go to 20s. Again, doesn't really matter, just a convenience thing. One, two, three. That we're gonna do. Define fan module. You can break off. Okay, what is this though? Why is this failing? The feature. Is it not? Oh, it's not liking that anymore. Mm-hmm. Yeah, so now we're chilling. That's flush, but it could be any. The exact for that particular bolt, for this one and the other one, size doesn't really matter. Or the length doesn't really matter. Kind of matters. Not really though. Mm-hmm. So that's what's keeping it retained. So I'll just have to pinch it in place when I go to install it. So we do want the other one. My computer is officially chugging. The model, and because of the stream, it's very funny. It's really not that big of a file. It's those filters though. I can suppress those. Mm-hmm. Bang. All right. Not in just gold. What is up? Not in just gold. Thank you for the compliment. This is... I got a fat 4-hour French Touch playlist. This is Penthouse Serenade by Alan Brax and Fred Falk off of the record The Uppercuts. I do so much Arduino stuff, dude. So much. Let me show you. I have a blog. Crop desktop transition. ESOLogic.com. This is like the tag cluster of the different topics I've written about. Arduino is one of the big ones. Is it the biggest one? It is the biggest one. Second to looks like Raspberry Pi. But yeah, I've done a bunch of Arduino stuff, man. I have pretty much owed the Arduino for my interest in engineering, which was like my choice of college and my major and then my job, and Arduino is life. I honestly though I haven't touched it in a while. This was 2022, last project I worked on. Mixed data engineering with IoT. Yeah. Oh my god. Me too. Me too. Yeah. Have you seen the freaking the thing that I cannot get over is so the Raspberry Pi Foundation, the new AI camera. So there's kind of a, so this is like a, okay, this seems buzzwordy, but there's an implication here that is really, really cool. So so this thing is like, it's like a camera. Let me get it. Let me see if I get a pictures. Photoshop. So there's the image sensor that's like interacting directly with an RP2040, and they don't show it. There's an RP2040, which is like just, yeah, you can see it right here. Little microprocessor that's like running something that has an AI model on it. The RP2040 is like $1. LCSC.com. RP2040. Yeah. This is $1.06. And it's like running an AI model. Like what? So because it's getting output tensors that are like getting fed with the frames. So like there exists a process, I don't know if it's available to us mere mortals yet, where you can like run AI inferences on something that is $1.06. So like they're doing it with like cameras, but it could, I know you're thinking what I'm thinking of, like this could, you could do all kinds of stuff with this if you can somehow like train the model and then get it down to a point where you can run it on a little microprocessors like this. You can get like, you could get nuts. You could do all of your train, like we know they didn't do the training for the AI model on this thing because it, I don't even know, it's like, what's the, they don't, it's got like, yeah, this much RAM. You can't train AI on this. But so the implication that I'm seeing with this is like, there, yeah, I know, gives me shivers. Yeah, so it means like you can do the AI part, big computer, and then somehow deploy it on $1 computer, which is like, okay, yeah, I'll drop the link in the chat. Yeah, this thing is cool. I mean, it's cool as a standalone thing, right? Of being able to do it. Like they have this object detection demo, so this is like real time on a Pi, which is amazing. But like to me, the other element of this is like, oh my god, you could do AI, you could do a mod, you could put a model onto this little tiny chip and then have it do, I don't know. That to me is like the insane part. But yeah, the data engineering IoT is like extremely cool. Extremely cool. I don't know what I would do though. Yeah, if you end up buying, yeah, I have no idea. I think, well, no, I think so I think the way it works is like it's running a model, like it's running a probably like a YOLO-ish model. You know, YOLO v3. This is like a it's like a real-time object detection. So it's like this is all over the place of like just going for, it's like very fast object detection. And so it's probably just running something like that there. So you're probably not training it, like it's probably just plug and play. Or my understanding is it's just plug and play. So it's like for every frame, yeah, for every frame you also get, this is what's in the frame, like in real time from the camera, and you don't have to do any processing on the Pi. Like it's just like boom, here's the contents, which is also insane, which is also really, really cool. But yeah, I don't know. I haven't bought one yet, but I will probably buy one. I will probably buy one, and that deserves a gong. All right. So now I got these retainers in. Very cool, cool, cool. Yeah, yeah. Eventually I'll get one. The stream, wait, check this out. So the stream, I got this other scene. These are Raspberry Pis. The cameras, this camera and this camera are both Pis. So I can do like overhead bench stuff. But for this project, it's in the video, but I'm gonna use actually a BeagleBone black that I have been sitting on for years. I have never used this, so I'm gonna use it for the project I'm working on now. But probably not gonna be AI, but gonna be definitely IoT. Like the plan is to do, for the fan driver modules, have like a web server running on here that's like, okay, change the speed of fan module 2 to X% power, etc. So not quite data engineering IoT, but definitely IoT. All right. I gotta get another light, because now I'm dark on this side, but that's okay. Thank you, thank you, thank you, thank you. Alright, so I wanted to now work on, so we got these retaining pieces now. No, it's going on a server rack. Hit the, yeah. Check that out. Yeah. The idea, it's going on a server rack. This server rack, which is a crazy CAD model. Yeah, it's going on a server rack. And there's gonna be 4 of them. Yeah. So it's gone on a server rack because it has that big glass front door that just like chokes out all the air intake for the servers, is like right up against a door. So we got to get air in there somehow, which is the plan for this project. Okay. So the next thing I wanted to do was like,
The people come together. Makes it feel good.
oh, dude, Justin, not Justin Gold. Thank you for the follow. Thank you, thank you.
That moves your heart.
Yeah, it's gonna get, my goal is to like get through the mechanical part, order components, and then while components are coming, start to work on the software side of it. So that's gonna be like the embedded Python, even though it's not, it's like a Linux OS, so it's not really, not MicroPython or anything, but for the controlling everything it's gonna do, I'm gonna do a little web API. Okay, so the next thing I wanted to do was just think more about this the air shroud, the guide shroud, or whatever I want to call this. No, yeah. So order the parts. I mean, when I say order the parts, I mean like order, like this thing is going to be printed. Oh, I'm on the wrong scene. Shit. This thing is going to be printed. But the fans, like the fans that are going to be installed, those are going to be ordered, and that takes a while, like 4 or so days. So while that's in the mail, while that's coming, and I'm probably going to do a circuit board for the for controlling the speed of the different fan modules, and that'll take a bit. So basically, like while stuff's in transit, I'll start on the software side, but first you got to do the hardware piece. Because that is harder to change. Alright, I'm actually gonna add the air guide thing to this part. Mock air guide. Okay. This is gonna be crazy. Why is it over there? Okay. Yeah, okay. So I think I do not really wanna go ham with this just yet, because I don't really know how I'm gonna manufacture this. Doesn't have to be, yeah. So if we do this, parallel, where did we go? There it is. Yeah, okay. So this is gonna be crazy to try to print. And I think I need to have a think about how I want to do that. Probably gonna do it in a couple of parts. But I know it's gonna be yeah, I'm probably gonna do 2, 4, 6, 8, 10, 11 bolts. So like one here, 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 and then one on this side. Yeah, that's probably... Let's just nail those in at this point, because then we can start working on the BeagleBone mount and the power inlet mount for the other pieces. Yeah. Because that way... That'll probably be where this piece starts to fork, is the BeagleBone configuration versus the regular power configuration. Yeah, but how am I gonna print this thing? All right, so let's add those holes. It's gonna be, again, nut pockets from this side. So yeah. Okay, so okay, so yeah, all right, this is gonna be easy. So let's do this one first. So we are gonna give ourselves $5 millimeters of inside plastic. Yep. We're gonna go. Yep. This. We're gonna use the same exact geometry from earlier in the part. This one. I'm gonna put this right smack in the middle of this segment. Bang, 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 bang. Midpoint. Okay. What did I do for this one? I literally forgot. What is this depth? 2.5. Crazy. I was wrong. So then we gotta go here. I'm gonna flip this. And we gotta blast this out the back. Okay. Here, oh. Yes, this is what I thought was gonna happen. We can go like this. 2 degrees of draft is okay. Yes, brother. Okay, so now. Yeah, you like the music? This is Justice. Never Ender. All right, so alright, so now let's do the hole for this. We are going to do the same thing as we did before. We are going to go, whoops, that's the wrong one. We're going to go concentric to the bolt cutout. And we're going to just borrow the hole size from right here. Yes. Okay. So now is the, you can pattern this. All right. The where, though, is the question that I am now confronted with. So, if we do two here, but just maybe I just have to pick. Stop fucking thinking about it so much. Okay. So the halfway point is here. So we'll do the 2 squares like this. Yeah, we'll do it like that. Because we know that this is the thinnest piece here. And we can make these equidistant like this. Honestly. And then we can just pick a standard number. let's actually base it. Let's put it in here. That means that the distance between these two holes is going to be the distance between these two holes. So this is a square, which we love. Okay. So now we have the base of the sketch pattern. Now we have to actually draw the sketch pattern. It's going to be here, 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 and here. So we now do sketch driven pattern. We have our sketch. We do this, bang, bang. Now we got all of the pockets. I'm gonna hide that. And then, whoops. Okay, yeah, you see these pockets? We're gonna mirror this around. The front plane. Boom. Okay, so now we have this thing is looking like Swiss cheese. This rocks. Okay. So these points here, and these ones too, are going to be roughly how this thing attaches. I haven't thought about how to do that quite yet. What's the gray thing like a vent? The gray thing is kind of the insane mode part of this project. So the thing that I was, so you know this, fellow Arduino fan, fellow maker of stuff. If you're going out of your way to build something for yourself, it should be perfect. If you're taking the time, if you're already down the rabbit hole of DIYing something, you want it to be better, significantly better than anything you could get off the shelf. So instead of just doing intake modules, my idea is to be able to vent the air to the front of the rack. So it is totally chaos in this model, but the idea is that the gray thing, you see it here? So this is going to be like roughly positioned. Let me try to get this better. Such that the air is vented from the sides, like right to the intake of the servers, which is up over here. And so I mocked this up really fast, so it's pretty ugly. But the idea is it's gonna bring the air in and put it right in front of the servers, which is like, but I don't, this is the, I feel confident in my ability to do the intake part. This piece is a lot more complicated. I'm calling it air guide, vent air guide or whatever. But so the idea, let me hide the door. Where are you, door? Yeah, okay, see? So it's too long right now, but I want to put it, I want to be able to park the air more towards the front. So it's like coming in from the sides, being directly to the front. Ideally, the servers are all breathing from the front, out the back, and then eventually I would want to do, so this is the back now, if you're following, have a exhaust fan out here that's like blowing the hot air out the top. So it's like cool air from the sides through the servers and then the hot air out of the top. So because we're doing 3D printing, we can like be kind of precise here. But yeah, so the idea is it's a event, yes, but it's like an air guide. But that's a bigger part of the project, or that's a harder design to do than just the like fan module piece, than just this piece, right? So that's why I'm kind of like just mocking it for now instead of having to do the whole thing. Super logical, it's sick, bro. Thank you. I think it's possible. Let me like make this. There's this shape is called a loft. So whenever you have like two like surfaces that are connected, so like you see the base of, it's like it's going from this square to this square, or rectangle to rectangle. That's called a loft. And that's like I'm still like new to using those. But let me try to make this a little better. So this is gonna be more like 20 millimeters. And this is gonna be probably equal to this. Okay, that worked. That's crazy. Ooh, actually, if that's equal, then I can print that pretty easily. Because I can just print it on its side like this. But this is also wrong. It's too long. Actually, I don't think it's gonna be that hard to even model this. Problem is I have a pretty small gap. Like you really want to hit it. Yeah, and this CAD model isn't updated. There's more of a gap here. Ooh, I can fucking... put this. Yeah. This is gonna make it crash. Oh, it worked. God damn. Yeah, so this is like more realistic ish, but I want it to kind of like, yeah, but then you got this problem, you running into stuff over here. Yeah, so this is kind of a tough design. Okay, getting distracted. This is where we're going though. This is Valhalla. If I can do this, I will be extremely pleased with myself for years, because this will be really useful. Okay. So now we got the attachment points for the, what should we call it? like a vent. Let's call it the air guide. So now we got the attachment points for the air guide. Chat is really good at naming stuff. I'm very bad at naming stuff. There was a dude that came in to talk over, or that was with me for a lot of this project. And he like named so many of the parts. So if you have ideas. This is a GPU cooler. Back in the day. Back in the mother freaking day.
Yes!
Yeah. I can talk more about it. Yeah, this project was awesome. Tesla cooler. So it's for the Tesla GPUs, which are for like data centers that you can get for like no money. So if you go to eBay and we search Tesla K80, yeah, 40 bucks, 34 bucks. And these things have 24 gigabytes of VRAM. They're very, very powerful, but they're useless for like the home user because they have no fan. So the idea is that they're installed in like data centers that have like forced air cooling in the chassis. Because like if you're a data center, you don't want to have a bazillion little tiny fans that are just gonna like break. You want like big heat exchangers that are easy to service, that are outside of the computers. So the idea with this project was make it cooler for that. This was actually, I'm actually still working on this project. I'm working on like commercializing it, actually, like trying to turn it into like a product because it was very popular. So definitely to be more on the stream about this in the future, because this is like I've totally completely gone down. This was like 3 years ago. I've totally gone down the rabbit hole in this project trying to like perfect it and make it usable with, yeah. You're teaching me so much. You're in college? What are you going to school for? You're very nice. You're very nice. You're very nice.
Yes!
I got my soundboard. What are you going to school for?
Step out through the bed door. Nothing but plain blue sand.
This part of the song is crazy.
Flat.
Masters for Business Analytics. Brother! Ugh. I want a master's degree. I'm jealous. I'm jealous of your grad school adventure. I got no time. I got no money. doing crazy stuff like this. All right, let's go for the mix. Yeah, the business analytics is like the whole ball game. There's so much like stuff. I work for my day jobs at a startup, and it's so funny how like just being able to see the board, like being able to see markets. Yeah. I love college too. I don't know what to do more. Yeah, PhD next. PhD. Not in dress gold. That'd be swag. Dr. Gold. Let's switch the vibe up. All right, let's get back to it. Okay, so now we got to do we got to add the nuts to these holes. I'm not in the right model. I am. GMAT, dude. All right, you about to go ham. What's the GMAT? Let me. GMAT exam. Graduate managed emissions test. Oh yeah, duh. Yeah, I'm sorry. My bad, dude. I gotta hit the booze, dude.
Betrayal.
Wrong. I know what that is. I've been out the game for too long, brother. I'll just jump into industry. GMAT doesn't go super well. Damn, it's a test coming up. Yeah, I mean, it's not going anywhere. At least this is what I'm telling myself about graduate school. It's not going anywhere. There's gonna be colleges. All the colleges you want to go to. All the universities you want to go to are still gonna be there. When the timing's right. And going to industry, business analytics master, you make yourself a little bit of dough with that. Yeah. No bad options. What you can't do is just you can't just sit though if you don't get in. You gotta make moves. I'm sure you've seen people run into that situation before. Yeah, exactly, yeah. This part has now like 4, 8, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 embedded nuts. Good thing they come in like packs of 100. We'll probably have to adjust this for doing the air guide, but I don't think it'll be that hard. So even if these move, it's not that big of a deal. Okay. I am going to suppress those meshes on the fans after this bolt, after this nut, because this is taking forever because my computer is slow. Okay, let's do that right here. Let's go to you. Let's go hide. Let's go hide. Let's go hide. Much faster. Okay. Where did those other two go? Four, five. Okay, I just didn't copy them. There are two more. One, two. Oh no, not coincident. Parallel, parallel, parallel. Mm-hmm. Okay. Mm-hmm. All right, so that is those nuts installed. Okay, let's export this and see how it would print. Because we got a lot of detail here now. So I'm going to do the split again. Okay. We can go to desktop, transition, save as. Desktop, bang, 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 all bodies. Alright, so this is the couple hours ago version. This is where we're at now. Okay. The question I have is about the nut pocket. Yeah, they'll be fine. Yeah. That'll be fine. Yeah, and that cross section is going to be way easier to print too. So if we do support on build plate only, print settings, support material, organic, slice. Whoa! Did I just clone that? Nah, delete. Alright, slice. Yeah, it's gonna catch those. No problemo. Alright, we still got people in the damn stream. That's sweet. Alright. This is a little weird. It'll be fine. This is gonna look nuts. Still cannot get over how cool organic supports are. Okay. Alright, next we gotta start configuring this thing to either be BeagleBone or either be the power input. Actually, what this unfortunately means we have to decide an orientation for this thing, which is not that big of a deal. But it's the kind of thing that eventually will cause heartbreak. So again, to what I was saying earlier, if we off-center the gadgets, so either the power inlet or the BeagleBone, like if they're back here, one, they're easier to interact with, and two, oh man, I could almost collide with that, which is interesting. Okay. Okay. This is doable. Time to lock it the fuck in. Time to lock it in, dude. I need my gongs. You know what I'm saying? Okay, we're gonna do it over on this side. Ooh, wait, no. If we do it like that, we're gonna have to have a... Hmm. Alright, fuck it. I'm just gonna start working on this. Okay, so we're gonna go... We gotta have a nominally... We need an orientation. I said that 10 minutes ago. Okay, so... We're gonna say that this is the bottom. So we know the fan cable is on this hole. Uh-oh, that's the record. We're gonna do... Who should we play next? Who should we play next? Well, YouTube next time, I think. Okay. I'm gonna do the wire here.
History, reality, transform energy, distance, dream,
Like this.
stars,
Oh, why is that? Why? I don't know. And? Yeah. Okay, so this is gonna be 15. I mean, I guess I really gotta hit that position. So the thing that I'm worried about here is
voices,
this wire.
dream,
Mounting holes there, there's a wire, which we have to like kind of thread perfectly. Yeah, we're not getting a drawing. Yeah. Let's do a little Googling. Detailed specifications. Yes, very detailed. 1 page. 1 page. click and hold the button. I am a human being. That is hilarious. Okay, DigiKey does not have a good data sheet either. Let's go to, this is MNB Technologies. I doubt this guy's gonna have it either. Oh, yeah. W. W. Of course, it's not noted on the drawing. I bet I could find a CAD model for this. Technical data sheet. Yeah. Ooh. AliExpress link. Huh? $288-watt air conditioner cooling system. That is so much power. Alright, I'm getting distracted by fucking AliExpress. Okay, let's try to find. This Newark one was good. MNB Technologies. This is axial fan. DC axial fans. Give me the CAD model, bro. Sleeve bearing. That looks more like it. Series data sheet. Yeah, we not getting CAD models, brother. I'm gonna have to buy one of these things. Or we can eyeball it. I'm gonna say it is halfway between the center line and this hole-ish. We're gonna do this. So we're gonna go, it's close, it's further than I thought. So go like this. Hit the midpoint. And We're gonna go 5 millimeters away from there. And we're gonna go 20 millimeters. And we are going to remember that this is not totally accurate. Right? We're gonna remember that. Yeah. So that's gonna be for that wire, and I gotta do a couple more. I'm gonna just do it in this sketch. I'm not gonna do a pattern. I'm gonna do like this. This, bang. You are here. Like that. So it means the wire is going to get in the way there. Which I suppose is okay. What did I just do? Why did this just move? Yeah, there. And then you here. Okay, so that it's kind of bad. So we're gonna have to rethink the air guide attach point, which is not a big deal, easy to change. But the wires are not, we cannot change where they are because they come on the fans. So we have to try to accommodate. Which is really not that big of a deal. I suppose I could just do a hole though. That's actually the play. We're gonna do I'm gonna do this. Again, because we are crazy 3D printing people, this is allowed. Yeah. And now the nut pocket also works. So I don't have to change shit. Okay. Let's go take a look at this. Okay. Let's go look at this in context. Alright, I'm gonna make those fillets instead. I don't really like the chamfers. Yeah, we're gonna have to definitely buy one of these before locking this down, because this is actually kind of tight right there. For sure. Alright. This is looking sweet. Not just in gold, dude. Not in just gold. My man. Thank you. It's very complicated. But that's okay. And we're also just kind of getting going here. So the next thing we gotta do is so the fans are going to be, so this is a DC, look at this, check this out, that piece there. That piece there is this. So this is going to be how we're going to power them. These DC fan or DC power inlets. So we're going to just wire them all together in parallel, connected to this. And then from there, the other end of this is going to be basically the BeagleBone. That's the plan. And I'm still getting used to this setup. I gotta stand up to go up there, but that's okay. All right. I think I'll probably do this last. Because we can cable manage through there.
must not ever forget the look in your eyes.
Okay, so now we can get fancy schmancy. So we're gonna split this to print it.
Be loved to sleep.
So like, it's gonna be split into basically into two parts. Ignore this. But the way we're gonna print it, because it can't be printed in one go the other way, the other orientation, we have to do it in two pieces. So now we can actually get fancy and have it. Does it actually work? It does not work. Alright, whatever. I'm gonna... Did I ever save this? No. So now let's start thinking about the BeagleBone. Because that and then the power input are the two pieces that have to be kind of supported here. My SolidWorks is opening the BeagleBone model, so now we wait.
Game over. Failure. Top five, top five, top five.
Alright, there you go. So now we gotta start thinking about this bad boy. This bad Larry. How do we want to position this? Holy God. Look how many files this just made. Glad I gave it its own folder. Okay. Okay. There's a couple things we have to consider here. The main one being is like, what do we need to get at from the BeagleBone while it's installed? We need to get at Ethernet port, probably. Yeah, the HDMI port is over there. Uh-huh. I'm thinking we do it like this. Because in an emergency, we can get at the video output. Hopefully that doesn't happen. Yeah. That's probably what we want. Get at the USB port. The Ethernet's going to be plugged in all the time. The power is probably going to be coming in from that side. Let's go look at it on the thing. I don't know why I have it in the... Okay, so that's not an insignificant amount of latitude right there. It's actually easier to think about up here too. Actually, I really don't. I don't think I'm ever gonna unplug the Ethernet cable. So it's just gonna get wound back up to the top. So if I plug the Ethernet cable in upon installation, I should never need to get to it again. And doing it, orienting things. At least this side of the Ethernet cable. The other side, like whatever I'm plugging it into, that'll probably need to change over the many years of this deal. But if we do... This gives us more room for hanging. What? It's fully... Oh, whoops. Yeah. This is the alpha position for stuff. So I'm gonna be powering it via undetermined. Is there a PoE cape for the BeagleBone? I will Google this now. BeagleBone PoE cape. There is.
From disco to disco, town across town. Everybody is trying to get down to the
And so it's not built in. So it's gonna have power input, it's gonna have, and then it's gonna have the 3 power outputs, which are all gonna be barrel jacks. Yeah. Yeah. Okay. So this is what we're gonna do. Okay. I think it's time to model this. All right. Damn, live for 5 hours. Okay. I think this is it for tonight. Mr. Gold, Mr. Not in Just Gold, are you still with me, my brother? It's time for me to sign off. Yo, dude, I'm out. I'm gonna stream next Tuesday. I think this is gonna be a Tuesday night thing. GG's, brother. Until next time. Until next time. Okay. Peace. I'm going live next Tuesday. Goodbye, goodbye, goodbye.